Hello everyone, this is Miss Nemet. 4.2 Graphing Quadratic Functions in Standard Form. Today's objective is to graph quadratic functions written in standard form. The vocabulary is standard form. So what is standard form? F of x equals ax squared plus bx plus c. And we have to see the values of a, b, c, and what kind of information they tell you about the graph. Remember, the vertex form of a quadratic function was a times parentheses x minus h squared plus k, where obviously a cannot be 0, because if a is 0, then there is no quadratic function, but only at y equals k, which is a horizontal line. And now the standard form is f of x equals a times x squared plus bx plus c. And naturally, a cannot be 0, because then it would be, again, a line. So finding the features of a quadratic function in standard form is really what I mean by dating the problem. We just look at the equation y equals negative x squared plus 6x plus 3, and we will immediately know everything about this parabola. Let's try. First, identify a, b, and c. And a is negative 1, b is 6, and c is 3. The first question is the vertex. The vertex's x-coordinate is located at negative b over 2a. So let's do that. Negative 2b over 2a is 3. How do I get the y-coordinate? I simply plug it in to the original equation. So y equals f of x. F of 3 is 12. Now I have the vertex's x and y coordinate. So the vertex is at 3, 12. What does that mean? I simply sketch the graph. It's an upside down parabola because there is a negative sign in front of the leading coefficient. And then the vertex means a maximum point of the parabola. H and k, the axis of symmetry, will be at x equals h in our parabola at x equals 3. Remember, that's a vertical line. And the range, obviously, the parabola does not exist above the highest point. So the range will be y, I am missing here an equal sign, is less than or equal to k, which means y is less than or equal to 12 in our parabola. Now, obviously, if the parabola is right side up, so if it looks like that, I'm going to have a minimum value, and the parabola is going to be located anywhere that is greater than or equal to k, which is the y-coordinate of the vertex. Our main objective is graph a quadratic function in standard form. So let's do that. What is the graph of y equals 4x squared minus 16x plus 10? Identify a, b, and c. Then find the x-coordinate of the vertex, negative b over 2a. It is 2. And then find the y-coordinate of the vertex by plugging x, 2, into the original equation. And after some calculations, we get negative 6. Now that we know that the vertex is at 2, negative 6, we have this point, the most important point. I can immediately plot that onto the graph. I do need 3 points to graph a pretty parabola. And I'm going to do that. The easiest point to do is the y-intercept. Where is the y-intercept? Where x is 0, so I plug in 0 for x and I get 10. Do you see that the y-intercept is always 10? Always c, I'm sorry, and that is why it is 10 this time. So I plot 10, and then I simply sketch the axis of symmetry at x equals 2 and measure the distance from here to here and plot the second point on here. As I have 3 points, I can graph a smooth curve, which is a parabola. Just to show you one more time, the vertex is going to be at 2, negative 6. the y-intercept at 10 and the reflected point here is at 4, 10. Convert a quadratic function from standard form to vertex form. We can use the vertex to write the vertex form of the parabola. So what would be 2x squared minus 3x plus 2 in vertex form? First, obviously, I have to find the vertex the same way we have done before. I plug in negative b over 2a, which is 3 over 2 times 2, which is 3 over 4. Yes, indeed, it's a fraction. To find k, or the y-coordinate of the vertex, I have to plug in 3 over 4 into the original equation, and I do that here. After some fractions, if you want to stop the video and figure out what I did with the fractions, I have 7 over 8 for k. So the vertex is 3 over 4, 7 over 8. I can write now the vertex form. What was the vertex form? Y equals 8 times, parentheses, x minus h, parentheses closed, squared plus k. All I have to do, a, I already knew that because a is right here up front. That's the only variable coefficient that is the same in vertex and standard form. So 2 times x minus 3 over 4 squared plus 7 over 8. Another problem to convert a quadratic function from standard to vertex form. It's a word problem. A model for the performance of a stock is modeled with this equation. D represents the days of trading, and P is the price per share. What is the maximum price per share of the stock? Now, obviously, if I have a parabola with a positive A, then this is going to have a minimum at k. The minimum value will be k. And then if the parabola is upside down, which means it's negative, the maximum value is going to be, again, k. So we have to find the vertex for this problem. The vertex is going to be at negative b over 2a, which is, again, a and b, and it's 25 over 3. Now, for this problem, I used my calculator. I have to admit that, because I didn't feel like working with fractions and big numbers at the same time. So, as soon as I plugged in 25 over 3 into the function, I got 208.33, which is the maximum price per share of the stock. And it happened at the day, which is 25 over 3. D, remember, is the days. Hooray! I can't believe this video is over. I hope you enjoyed that, and I also hope that you understand every single concept in this lesson.